Hello everyone, welcome to my channel The Scientific Learning. In today's video, we will understand what is fault tree analysis, that is FTA, what is its purpose, and how to construct a fault tree with practical examples. Let's begin. What is fault tree analysis? By definition, it is a top-down graphical method used in reliability engineering to identify the root causes of a specific undesired event. We can underline two things from this definition. Firstly, as I have highlighted here, fault tree analysis is a root cause analysis technique. In fact, the definition of root cause of any problem is rich. It is the fundamental, underlying, and often hidden reason when a problem occurs. Identifying the root cause involves finding the lowest level cause that, if removed, prevents the entire issue from recurring. And secondly, it is a top down approach. By that I mean we start the fault tree analysis with the top event and then go down to the bottom of that event, that is the basic event or the root cause. Now, constructing a fault tree analysis provides a structured and logical way of identifying the root cause of the event. It is a visual technique. It is a simple but powerful technique for arriving at the root cause of the event. Two types of FTA exist, as shown here, qualitative and quantitative. In qualitative FTA, the root causes are identified without attaching any probabilities, whereas in quantitative FTA, probability of the top event is calculated based on underlying events. Moving on. This slide shows an example of the fault tree. We will go into the details later. I want you to see the structure of the fault tree here. It starts with the top event, which is shown in the rectangular box, which can be a system failure or any undesirable event that you want to analyze and find the root cause. We can see the OR gate here, which is used when multiple root causes exist, for example A, B, C and D shown here, represented by circles. So what are the prerequisites of fault tree analysis? Can I start constructing a fault tree with some working knowledge of the top event? The answer is no. Firstly, we require a thorough knowledge of the system or process that is to be analyzed in the fault tree. Fault tree analysis is only a systematic way of organizing already available knowledge. So one needs to have a thorough understanding of the system involved. And secondly, to construct a fault tree, we need to know the symbols that are used in the analysis. We need to know about the gates that are used there, for example AND, OR, inhibit gate, etc. We will learn about these with examples. Now let's see how to construct a fault tree. Start with the top event, which is shown by a rectangular box. Identify intermediate events causing the top event. Find the relationship between the top event and the intermediate events using different types of gates, and end with the basic events or the root causes, which are shown by circles. Let us take an example now. As I am an electronics engineer, I will take the failure of an embedded system as the top event, shown here. Now the embedded system failure could be due to the power supply failure in it, the CPU or motherboard failure in it, or it could be due to the communication failure. These I have shown in rectangular boxes to indicate that these are the intermediate events which are causing the top event. Because multiple events are there, we have used the OR gate. And OR gate, as mentioned earlier, is used to indicate that any one of these can lead to the top event. We can go further down to understand what causes power supply failure, what can cause CPU or communication failure, and keep going down as long as it is meaningful to the problem at hand. Now let us take the example of the CPU failure and go further. Now this CPU failure could be due to the RAM failure as shown here, or it could be due to the processor chip failure, or it could be due to the voltage regulator failure. Here, by showing these causes in circles, I have called these three as the root causes, and this is where I stop the analysis. Now A, B and C become basic events or root causes relative to our analysis depth requirement. In the case of system FTA, which I have taken the example here, a power supply failure or a CPU failure, basically the module failure itself could be the basic event. But when we do the board level FTA, we can go down into the chips and identify which chips could be the issue. And if we want to do chip level FTA, for example, if we want to do the fault tree analysis of a RAM, then we would have to go into the silicon level or the solder joint level and so on, depending upon the context. Now we will see a second example, power supply failure in a server. Once again, this failure could be due to component failure or a short circuit failure in the power supply, which is a very common issue, or it could be due to overheating and powering off of the power supply. Going further, here now component failure could be due to two reasons. It could be due to a random voltage spike which is causing the component to fail, or it could be due to aging also. If we consider overheating of the power supply module, I have used the AND gate here to indicate that both loss of the air conditioner in the room in which the server is placed and also loss of the cooling fan in the server together will cause overheating of the power supply module, which will lead to its failure. And here in this example, we have used both and OR gates. So for any generic case, how does one know when to stop the fault tree analysis? We stop doing the analysis when we hit events such as component failure, human error, or environmental condition. We stop when further breakdown adds no value and we have reached physics level detail and going further down adds no meaning. And then these basic events become the area of focus to improve the system and reduce the top event occurrence probability. And finally, applications of FTA. Where is FTA used? It is used in both qualitative and quantitative reliability assessment as discussed earlier. It is used to improve system design, wherein it is used during the early design phase to identify single points of failure. For critical systems such as in nuclear, avionics, etc., single points of failure are not acceptable and thus are eliminated by employing redundancy even before a product is built. So this is how FTA helps in design improvement. And thirdly, it is used for safety certification. In high-risk industries like aerospace, nuclear, healthcare, FTA is often a mandatory part of the certification process to prove a system is safe for operation. If you wish to see more videos on reliability, comment, like and subscribe to my channel. Thanks for watching.